Okay, a very good morning. In this lecture, we are going to see how we can obtain circuit diagram from test on on three-phase induction motor. So we know that how we can conduct test on three-phase induction motor, no load test and block rotor test. So the data which is obtained from no load test and block rotor test can be utilized to obtain circuit diagram. So from no load test we will be having stator voltage, input current, input power. The no load test, that is conducted at rated voltage. So whatever value you are going to get it under no load condition, that will be no load values. So this no load current, what you are going to get it here, the input current, you could call it as no load current, that is going to show you, it can be shown basically here by drawing this line OQ. Here it is your reference line. You can say V1 can be drawn, and then this OQ, which is going to represent your no load current, that can be drawn by taking an angle of theta 0. So here the angle between V1 and your no load current, that will be theta 0. And what is the theta 0? Theta 0 is your no load power factor, which is given by this expression. So theta 0, that will be equal to cos inverse PNL divided by VNL into INL. You can consider a suitable scale in order to draw, in order to represent that particular value. Now from block rotor test, you are going to get certain data. This test is conducted by applying fraction of voltage so that rated current flow in the motor. So you are having the data, that will be block rotor voltage, it will be fraction of rated voltage, input current, here it will be the rated current, that will be your block rotor current, and input power. So basically when you are conducting this test at fraction of voltage and you want to represent various operating parameter of induction motor on circuit diagram, you must convert it into per phase voltage V1. So basically whatever value you are having, it will be converted to per phase value. So the value, the short circuit current, that will be given by IBR into V1 divided by VBR. Short circuit power, that will be given by block rotor power multiplied by V1 divided by VBR whole square, and the power factor angle or the short circuit power factor, that will be given by PBR divided by VBR into IBR. You need to again convert into the rated applied per phase voltage. So just substitute its value from here, respective value you can calculate from here and substitute, you are going to get this value. So now we are having ISC, PSC and cos theta SC. So when you are having ISC, so you can draw ISC, that will be given by basically OD line. So taking suitable scale, you can draw this value OD. Okay, and the angle is already with you, theta SC, so you have to take that angle from V1. So it will be drawn at an angle of theta SC. You have to draw a line OD. Now how long it has to draw, that we will talk about that. So particularly how long it should be, we know that the D, it should lie on a circle. Okay, so your point basically Q and D both should lie on the circle, or you can say on current locus. It should be there. So what we need to do in order to draw that circle, we must determine the center of the circle. What will be the center of the circle? So what we will do in order to determine that, first V1 is drawn. So we are going to draw this axis OX and this QR, which will be perpendicular to V1. So now you are having two horizontal axes OX and QR, which is perpendicular to this V1, and its right bisector, which is joining the line this Q and D. Okay, it is going to meet somewhere here in this line QR. So wherever you are getting this bisector, okay, that will give you basically the center, and you can say this is basically center of your circle diagram. So C will be your center. Once you are having center, now you can take either CR or CQ as a radius, and then you can draw the circle. So both point, this Q and D, that is going to lie on the circle. Both must lie on that circle. So circle will be drawn later on. Before that, you need to find out the circle C, how we have drawn it, how we have identified it. So basically we are having V1, we are having a line QD that is with us, and we have drawn horizontal axis. This axis basically OX and QR, which is perpendicular to V1. Then what we have done, we have determined the bisector of the line QD. So basically when you are going to get its bisector, so you are going to get this circle, center of the circle, you could say. So when center of circle is with you, so considering this radius, you can draw it. Now what you can do, you can draw, now you are having the point D. So D is with you, so you can draw a perpendicular to this horizontal axis OQ. So you can draw a perpendicular DE, so it is going to give you certain value. Now you are having DE, so what would be the next step? It is obvious that we are going to find out the point G. So how it can be find out? The G will be find out in such a way so that this DG is going to give you R2, and the GF, it is going to represent R1. And you could say alternatively the ratio of DF by GF should be equal to ratio of R2 by R1. So this point need to be determined. Once you have determined this point G, then what you could do, you could connect it to the point Q. Now you can connect this line Q, G will be your having line. So basically it is going to give you top line before you are having the output line. Now you can consider any operating point. It could lie on the circle somewhere. Suppose this is the operating point P. So once you are having the line P, this operating point, you need to take a perpendicular. So once perpendicular is drawn, so now you are in position to indicate or find out all other operating parameters. So now you are having this point P, just connect this line with O. Point P is connected with O, so this is going to give you the input current or stator current I1. Okay, so this would be with you. Now I1 is with you, so the angle between I1 and V1, that is going to give you the theta m, or you can say on stator side power factor angle. So I1 is with you. Now you are also in position to find out, identify the output power. So here where you are going to get the intersection from this point Q on this line DP perpendicular, wherever it is going to cut, you can say that point is A. So this AP is going to give you power output. So you could say this AP is power output. You could draw also output line that can be drawn. So output line here where it is going to intersect, what you need to do, you need to just draw here one line D to Q. So it is going to intersect PD somewhere. So this point you got A, and after that when you are connecting this G to Q, this is going to intersect again on this line PD. So this will be your point B. So this point B, and between this A and B, this is going to give you rotor ohmic loss. Wherever on this DP line this QR is intersecting this point, you could say this point is a C, small c we are considering it. So the BC is going to give you stator ohmic losses. Then this C and this point D, it is going to give you friction and windage losses. This is with similar to the circle diagram. In circle diagram we know that this line is indicating this loss, this particular portion is indicating this parameter, operating parameter of three-phase induction motor. So once it is drawn, now you are in position to draw the other things like the maximum power output line, that will be drawn in the similar way what we have seen in case of circuit diagram. So basic use what you have seen, how it can be determined basically from the no load and block rotor test. Earlier we have used the no load test in order to get this point OQ. This no load current is first determined, okay, and you need to take this V1 first, and after taking V1 you are having the no load power factor angle, so you could draw the no load current. So one thing we have drawn with this no load test. After that block rotor test, we are having the short circuit current, we are having the short circuit power factor angle, or you can say power factor, and the short circuit power, that is with us. So once that is obtained, what we have done, we have drawn OD line, because we are having the angle, the theta SC is with us. So V1, with V1 you could draw OD with an angle theta SC. After that, now you are having 2 points Q and D, so it must be on that circle, on circle diagram, or you can say it should be on the current locus. So now you are having this one. So what we have done after that, we have drawn the perpendicular to this V1, QR and OX are drawn perpendicular to this one. Now we are having the horizontal axis. So what we are in position, we can bisect this line, basically QD. So it is going to be bisect, and wherever on QR you are going to get where it is going to touch this line, that will be your center of circle. So now you are having the radius. So Q, C or CR you can take, and you can draw a circle. Once circle is drawn, you need to assume what you need to find out what is the operating point. You can consider somewhere operating point could be here, it could be here, it could be here. So wherever is the operating point, just identify that, and from that take a perpendicular. Then you can join this OP, and other things could be drawn now. So once you are having circle, you can draw other lines which are going to represent various things: input current, power output, rotor ohmic loss, stator ohmic loss, friction and windage loss. The input power, that will be this one, dP will be your input power. Torque, that can be obtained when you are dividing it with omega s, so that would be your torque. Then slip, that will be gained by VA divided by BP, power factor dP by OP, efficiency AP by dP. So it can be shown into this diagram. So that is all about drawing circle diagram from test data. So if you are having the no load test data, you are having block rotor test data, so you could draw the circle diagram. That's all about circle diagram.